Good afternoon, Science 10s. Mr. Thompson here. What we're doing is we're studying 2.4 on mechanical energy. So we've studied potential energy and kinetic energy in the last two sections. So now we're looking at mechanical energy, which is the sum of kinetic energy and potential energy in a system. The mechanical energy in a system is constant. And so the mechanical energy, shown as EM, is equal to EP, potential energy, plus EK, kinetic energy. Here's the formula for potential energy, and here's the formula for kinetic energy. So it goes on. If an object is dropped from a height as it falls, it will have both potential energy and kinetic energy. As the object falls, the potential energy will be converted into kinetic energy. So a change in kinetic energy occurs because a change in potential energy has happened. Okay? Now the change in potential energy is shown right here, change in mgh, okay? And the change in kinetic energy, the change in 1/2 mv squared. So think about an object that's dropped off a building, like shown here. So at the top, it has all potential energy, and it's not moving, so no kinetic energy. As it falls, though, it has some potential energy and some kinetic energy. Where did the kinetic energy come from? From a change in potential energy, because the potential energy decreases as it gets closer and closer to the ground. It's not as high as it was before. At the bottom, we'd say that all the kinetic energy is in the system here, and there's no more potential energy. And we're talking about not when it lands and hits the ground, but just the instant before it hits the ground. Now we're assuming that in this system that there's no energy lost due to something like friction or air resistance, so we're not including those in our calculations. Let's try a few practice problems together, okay? Example number 1 I'll do. A cat has 80 grams, okay, 80-gram mouse in its mouth and is running at a speed of 1.5 meters per second. The cat and mouse are on a fence 2 meters above the ground. What is the mechanical energy of the mouse? Okay, so the mechanical energy, EM equals EP plus EK. Now you can put EP first and EK second or vice versa. It won't really matter. Let's sub in what we have. This is mgh. This is 1/2 mv squared. Now notice, it gives us the mass in kilograms. We want to make sure we use that. And it happens twice in the formula. Sorry. And now the calculation. All right, I get 1.6596. So I look at up here for the significant digits, 2, 2, and 2. I'm going to round to 2 significant digits, 1.7 joules. Question number 2. Lisa drops a stone from a bridge into a river below. The stone has a mass of 200 grams. When the stone is 15 meters above the water, it has 44 joules of energy. What is the kinetic energy of the stone? Total mechanical energy is the sum of potential and kinetic. Now this is what I really want to figure out. I can figure out the potential energy and I know the total amount of energy, the mechanical energy here. So I solved this for kinetic energy. Now I can go ahead and put in what I have here. I'll just leave this as EM for one more step and then subtract mgh. Now the mechanical energy, 44.0, and subtract away the mass. Now 200 grams, decimal 2 kilograms, times 9.81 times 15 meters. So 44, take away 0.2 times 9.81 times 15. 14.57, so we're going to round this to 3 significant digits, so 14.6 joules. Okay, question number 3. A flower pot has a mass of 10 kilograms and is sitting on top of a building that is 20 meters high. the flower pot accidentally falls to the ground below. What is the maximum potential energy the flower pot has? Well, in part A, we have a mass, we have acceleration due to gravity, and we have the height. So the total energy is EP. EP is at max, EK equals 0. So the potential energy is equal to m times g times h. 10 kilograms multiplied by 9.81 multiplied by 20 meters. $1962. I'll write that full number down, okay? And I'll go ahead and round it appropriately. So I want 2.0 times 10 to the third joules. Okay? In B, as the flower pot hits the ground, how much kinetic energy will it have? Okay, so that means that EK is at the maximum, and EP, potential energy, is going to be 0. And so any change in kinetic energy happened because of a change in potential energy. Change in potential energy is going to be 1,962 joules. So the kinetic energy here should be 1,962. So of course, since potential energy is 0 and it had all of that energy, well, where did it go? It went into kinetic energy. In part C, what's the velocity of the flower pot as it hits the ground? The formula for kinetic energy Now we can go ahead and solve for V. Now in the workbook, in the module 2 that you've been working on, they like to solve the equation and then sub in the numbers. You can sub in the numbers. I did that in my previous lesson. Here I'll solve for it. I'm going to multiply by 2, divide by m, and so I'll have 2ek over m is equal to v squared. And so v is going to be the square root of 2ek over m. 2 times 1962 divided by the mass, and the mass is 10 kilograms. Don't forget to square root, okay? And I get 19.8, and so it should be 20 meters per second. I'll put 19.81 and round it to 20 meters per second. All right, I'll show you another 2 examples on the next page in the next video.